welcome to Scholars Forum again. Hope you are doing wonderful. Well, I have come back again with my calculation problems. So for as many of you who are actually eating before viewing this video, just finish the food first before you continue so it doesn't taste too bad in your mouth. Alright, so we'll be taking complex numbers now. I see that it's the last topic in your handout, but then, for the sake of as many who are not students in our schools, okay, we'll be taking complex numbers in whole. Alright? Complex numbers. Now, if you can remember, under number systems, we explained complex numbers very briefly. Okay? And in complex numbers, what we said was if a number is not possibly expressed in digits, okay? If we cannot basically express it in standard form, then we could just call it what? Complex numbers. Alright? Now, take for instance, like what we did earlier, the square root of minus 4. Actually, square root of minus 4 is mathematically not possible because we don't take the square root of negative numbers. Okay? So in this case, I just change this to what? Square root of minus 1 multiplied by square root of 4. Okay? So this square root of minus 1, according to complex numbers, square root of minus 1 is I. So I is square root of minus 1. Okay? Now square root of 4 is 2. Square root of minus 1 is I. So when you multiply that, that gives you 2i. So you can see 2i is not a real number. Alright? 2i is not a real number. 2i is a complex number. Now generally, complex numbers are represented by things like this. Z equal to a plus bi. Okay? And some textbooks go as far as using or go as high as using x plus yi. Anyone you see, it is still complex numbers. Now, in this particular course, in this particular topic, we won't be going into much of talking or straight into work because we would like to cover it as fast as possible for the sake of those who have issues staying for a very long time on YouTube. So, yes, going further, z is equal to x plus yi. This is how all complex numbers come. Take an example. Z equal to 4 plus 2i. Okay, another example, z1. Another example, minus 2 plus 3i. Another example, 0 plus 4i. Another example, 2, let's see, 3 over 2 minus 7i. So you can see, in these examples you are seeing, okay, all these parts you see, every of these parts you are seeing right here, all of these parts are called the real parts. So we call these parts the real parts. Alright? We call everyone having the letter I with it. Okay? We call them the imaginary parts. So you can say this imaginary part on this side, minus 7i, you say 4i, you say 3i, you say 2i. All these are the imaginary parts of this complex number. Okay? So the complex number in total here, x plus yi, here 4 plus 5, 2i, minus 2 plus 3i, and going like that. Now all complex numbers undergo every operation in mathematics. Namely addition, subtraction, multiplication, and division. Now we're going straight into addition of complex numbers. Now in addition of complex numbers, take for instance, zi is 2 plus 3i and z2 is 3 minus 4i. Now it's very simple and straightforward, okay? Now should there be a case like this, all you need to just do is add the real part to the real part and imaginary to imaginary. Now this is for addition. So in this case, where's the real part here? 2, the real part 3. So if I add 2 plus 3, that means z combined will give you what? 5. Alright, 5. 2 plus 3, 5. Then 3i. What do we have here now? Now many of you get confused when you are working with things like this. So I would advise you, when you are working with things like this, make sure you respect the signs before and after each of the variables that you are working with. In this case, you have a plus 3i, here you have a minus 4i. Alright, so at the end, you are having a plus 3i, and you are supposed to do addition. Plus, in brackets, what is here? Minus 4i. So at the end of the day, you get to do plus multiplied by minus. That which gives you a minus at the end. So you have a plus 3i minus 4i. So I have plus 3i, I have minus 4i. Okay? Plus 3 on the number line. Where does it go? 1, 2, 3. This is plus 3 on the number line. Okay? Let's actually go back by what? Minus 4. Minus 4, going back by 4 times. 1, 2, 3, 4. 4 here is what? Minus 1. Okay? So in another illustration, it is you saying you have 3, okay, but then you need 4. How many is remaining for you to balance? 1 more. So you have a minus 1. Okay? Now, I'm sure that many of you are familiar with the fact that when we are writing in mathematics and the answer you get beside a variable or beside a value is 1, automatically you skip that 1. Okay? So in this case, plus 3 minus 4i will give you minus I. Okay? So when it gives you minus I, that means our final answer here is what? 5 minus I. Are we clear on this part? Alright, now the second part, which is subtraction, okay, just as we did for addition, your subtraction goes the same way. This time around, your operation is different. So in this case, you'll be having z equal to 2 minus 3 minus 1. Then 3i minus 4i, let's come down here, plus 3i, we did plus it before, so we change it to minus, okay, minus times minus gives you a plus, alright, so plus 3i plus 4i, so I have 3, I have 4, all together, I will now have 7i. So now you can see that the sign at the front is no longer a negative, it is now a positive. So you come all the way up and then plus 7i. Now that is all for subtraction. Now how about multiplication? Now this is where you would want to pay attention before we go into division. Alright, so for multiplication, I have z1 and z2, 2 plus 3i and 3 minus 4i to multiply themselves. So z1 against z2 is equal to 2 plus 3i multiplied by 3 minus 4i. So we do the normal expansion, alright? This will be 2 multiplied by 3 gives you 6. 2 multiplied by minus 4i gives you minus 8i. Now 3i multiplied by 3, that gives you a 9i. 3i multiplied by 4i is where I want you to pay attention at. 3 times 4 gives us 12 plus 3 minus 4 plus 3 times minus 4 minus 12. I times I squared. Now I will draw your attention to something before we get to the final of this answer. So this is 6 minus 8i plus 9i. So I have a minus 8, I have a plus 9. Minus 8 plus 9. So I'll be looking for minus 8 on the number line. And I'll be moving forward by 9 places because of the plus. Okay? So at the end of it, I'm having minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2. This should be enough to give us our answer. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see that, the plus 1. So that means we have a plus 1. And when I say, before we already said, when you have 1 as your standing value, you simply leave it alone and write what? The value there, okay? Now plus I, then minus 12. Now who can take a wild guess what I square will be? Remember we said in the beginning that the complex numbers is equal to what? I equal to what? I equal to square root of minus 1. Okay, so how about I square I? What happens? When I square I, here also will be squared, okay? Thereby cutting what? Your square root away from your square, alright, leaving with what? Minus 1. So that means I square is equal to minus 1. So that means in this place here, I will not be writing I square anymore. I'll be having minus 1. So this will be 6 plus I. Minus times minus becomes a plus. 12 times 1 becomes 12. So 6 plus 12 becomes 18. Then plus I. Finally, you have done your multiplication. Now, this is how we run multiplication for complex numbers. Alright, now going further to division. Let me make space. Okay, now for division, also you have to pay keen attention on this part because your Z1 divided by Z2 is equal to Z1 over absolute Z2 multiplied by, now I'm sure that somebody is beginning to think what exactly we are doing here. Alright, now just calm down. Now Z1, okay, multiplied by the absolute of Z2, over absolute of Z2 multiplied by your Z2 conjugate. Okay? Now, I know a few of us might be having to ask how exactly we got to this part. Now, let me explain this formula again. Now, your Z1 divided by Z2 gives you Z1 multiplied by Z2 conjugate over the absolute of Z2 itself. Okay? Now, what is conjugate? I think we forgot to mention that when we started during. Now, let's quickly run and catch up on what conjugate is. Now, in complex numbers, take for instance Z equal to X plus yi. Right? The conjugate of this is the opposite of the sign connecting your real and your imaginary. So in this case, X plus yi, the conjugate, which will be given by Z bar, is given as X minus yi. Also, the change there, let's return it back to the beginning. So Z was initially this. Therefore, Z conjugate will be the opposite of what? The sign in between them, minus. So whatever you're doing, if there was a negative at the front here, and you are doing the conjugate, you don't change the negative at the front here. You change the sign connecting the real and the imaginary part. Now that being said, let's fly all the way back to division now. Alright? So now in your division, with the same example we have to multiply Z1 against Z2 conjugate. So we have to find Z2 conjugate first. Now what is Z2 conjugate? Z2 conjugate. Z2 itself is 3 minus 4i. So 3 minus 4i, conjugate of it becomes what? 3 plus 4i. Now that is one part settled. How do we find the absolute of Z2? Now Z2 itself is what? 3 minus 4i. So the absolute of 3 minus 4i is equal to, when you're looking for an absolute will be equal to the square root of the real part, okay? X all square plus the imaginary part, all square. Okay? So in this instance, square root of x here is 2, all square, 2 all square plus the next, sorry, let me reset 2. So sorry about that. So this is 3 all square plus minus 4 all square, all to the square root. So the square root of 3 square, 9, plus minus 4 in 2 places. Minus as minus as a plus, 4 times 4, 16. 9 plus 16, so we have square root of 25, which is equal to what? 5. So that means the absolute of what we're looking for is 5. Okay, so that means we'll be dividing back to the formula now, coming all the way down here. We'll now be having Z1, 2 plus 3i over Z2 absolute, 5, multiplied by the conjugate that we have here, 3 plus 4i. I guess this place will not be enough for us to work, so let's go to the other end. Okay. So bringing what we have from that end, Z is 2 plus 3i. Z2 absolute is 5. Now, Z2 conjugate is 3 plus 4i. Now, let's work with this. So we have Z1 multiplied by Z2 conjugate, which is 2 plus 3i over 5 multiplied by 3 plus 4i. Okay. Now, this is what we finally have as our end of discussion. Okay, so this is, let me say this. 2 plus 3i multiplied by that, 2 plus 3i into 3 plus 4i over 5. Now 2 multiplying 3, that is 6. 2 multiplying 4i, 8i. 3i multiplying 3, 9i. 3i multiplying 4i. Now don't forget what we did before. This would be a plus 12i squared all over 5. But then when you go further, 6 plus 8i plus 9i, 17i. Here, I squared becomes minus 1 for the last one that we did. So minus 1 times 12 becomes minus 12. Minus 12 all over 5. So this will give us 6 minus 12 minus 6 plus 17i over 5. Now, if you remember what we said about complex numbers, they must have a real part and an imaginary part. So this means the 500 can be distributed to minus 6 and 17i, so they can stand separately. So that means this becomes minus 6 over 5 plus 17i over 5. Now, this actually closes the whole section of complex numbers. These are all the operations that complex numbers can carry. I believe you've learned a thing or two. If you have any questions, hit us under the comment section. Alright, until then, bye for now.